Alright, today we're going to go over the solving equations worksheet. There's 20 questions. Subtraction, property of equality. The reason we're writing that is so you can reiterate that when you see addition, you subtract both sides to get rid of it. I end up with negative 4x equals negative 22. Now, there's no more addition, there's no division, but look, there's multiplication. How do I get rid of multiplication? By division. That's called the division property of equality. And that's just once again, we're writing this so we reiterate that if I tell you that if you see multiplication, you use division on both sides to get rid of it. I'm left with x equals, I would leave this as positive 11 over 2. You might write 5.5, and I would take that because the decimal ends. All right, you don't have to like terminate it or round it. So now my last step is my check step. Negative 4 instead of x, I write 11 halves, or I'm going to put 11 halves. You could put 5.5 plus 7. Does that equal negative 15? All right. Negative 4 times 11 is negative 44. Divided by 2 is negative 22. Plus 7 is negative 15. That works. Boom. This is our check step. All right. That's it for number 2. All right. Number 3. I have 9x plus 42 equals 69. Same exact concept as before. I'm going to write PEMDAS. I'm going to minus 42 from both sides. I get 9x equals 69 minus 42 is 27. Now remember, the reason I'm allowed to do that is there was no subtraction. Addition tells me that I have to use subtraction on both sides. That's the subtraction property of equality. There is no division, but look, there's multiplication, so I divide by 9 on both sides. I get x equals 3. Now I have to check my work. Now remember, the reason I was allowed to get rid of that multiplication was the division property of equality. So I say 9 times 3 plus 42, does that equal 69? 9 times 3 is 27, 27 plus 42 does equal 69, so that's your check step, it's good. That's your final answer. The circle part is your final answer, okay? That's it for number 3. Alright, number 4, I have minus 8x minus 12 equals 42. Once again, I write PEMDAS down. There is subtraction. See, right away I see subtraction. How do I get rid of the subtraction? I add 12 to both sides. That's called my addition property of equality. I'm hoping you guys realize that if you see subtraction, that's why we're writing the add POE, so you have to remember, add 12 to both sides. That gives me minus 8x equals 54. Alright, so we got rid of subtraction. There is no addition. There's no division, but look, I see multiplication. That's why I divide both sides by negative 8. So there's a bunch of different ways to finish this answer. A lot of you guys are going to put x equals, remember that's the division property of equality. A lot of you guys are going to put x equals 6.75. I will take that because you didn't round it. That's exactly 6.75. Maybe you put 6 3/4. I probably would have left it as 27 over 4. Any of those three are options. Now you're going to check your work. Negative 8 times 27 over 4 minus 12. Does that equal 42? It's good to go. Alright, that's it. Moving on. Alrighty, 5 could be a little bit more complicated. It's 1 plus 2/3 y equals 27. Most people see the fractions, they just freak out and say they can't do it. But it's actually not that difficult. I'm going to write my PEMDAS. And I don't see any subtraction, but I see addition. I see 1 plus 2/3 y. You might want to write it as 2/3 y plus 1, because really, I'm not going to subtract 2/3. I want to get rid of this 1 right there first. I don't care about the plus 2/3. Alright? So maybe you want to rewrite it. That will make it look more like one of the earlier problems. You don't have to. But then it's a little bit easier to see that you subtract 1 from both sides first, and that's your subtraction property of equality. Now I have 2/3 y equals 26. It really depends on how you think of fractions. I think of fractions as 2 divided by 3, so I think I have division going on. I am dividing by 3. So to get rid of that division, I have to multiply. That's why I'm going to multiply both sides by 3. The 3's cancel on the left. I end up with 2y equals 78. Divide by 2, divide by 2. That's our multiplication property of equality. There's our division property of equality. And I get y equals 39. Now I'm going to check my work. 1 plus 2/3 times 39. Does that equal 27? And it works. So that's good. Alright, 6. Same exact concept. PEMDAS. Oh, look, I see subtraction, so I add 1 to both sides. That is my addition property of equality. I get negative 15 equals 3x. There is no more addition. There is no division. I have to use multiplication. I divide by 3 on both sides. So I get negative 5 equals x. Remember, that was my division property of equality. Now I just got to check my work, because that's my final answer. Does negative 16 equal 3? And instead of x, I write negative 5 minus 1. It works. Alright? Alright, number 8. Do PEMDAS backwards. So I'm going to add 3 to both sides because that's my addition property of equality, and I have subtraction going on. So I got rid of that using addition. Boom, gone. I get 3/4 y equals 12. Now how do I get rid of that 3/4? Let's just multiply by 3/4. I end up with y equals 12 times 3 is 36. 36 divided by 4 is 9. Final answer is y is equal to 9. Plug it in. Does 3/4 times 9 minus 3 equal 9? Think it works. Moving on. Alright, number 9 is 8y minus 5 equals 43. Same exact concept. I see subtraction, so I add 5 to both sides. That is my addition property of equality. Now I have to divide by 8. Divide by 8, I get y is equal to 6 because of the division property of equality. That's my final answer. I just have to check my work. 8 times 6 minus 5, does that equal 43? It does. That's it for number 9. Alright, number 10, we have minus 4y plus 28 equals 72. So once again, if you're lost, first thing you do is you write PEMDAS. Start at the bottom. Do you see any subtraction? I don't. Even though that negative 4 there, it's negative 4 times y. That's multiplication. But I do see addition. That's why I have minus 28 from both sides first. I get negative 4y equals 44. Okay? That's our subtraction property of equality if you didn't write it down. Now, I don't have any more addition. There's no division. Oh, look, there's multiplication because it's negative 4 times y. So I have to divide by negative 4. So remember, a positive divided by a negative is a negative. So y equals negative 11. Remember, that was our division property of equality. So that's my final answer. Just have to check my work. Negative 4 times negative 11 plus 28. Does that equal 72? It works. Moving on to number 11. Alright, 11 is negative 7 minus 15w equals 23. If you wanted to, you could flip it. You could write it as minus 15w minus 7 equals 23. It might be a little bit easier that way. I'm not going to do it that way this time, but that might make your life a little bit easier. Still, even if you don't flip it, it's still the same concept. PEMDAS, alright? Now, the subtraction is actually right there. That's the subtraction, the minus 7. Alright? It's not the minus 15, because that's minus 15 times w. That's actually multiplication. So when I get rid of subtraction by addition, using my addition property of equality, I actually add 7 to both sides first. That's my addition property of equality. So if you end up adding 15, you messed up. You get minus 15w equals 30. Divide both sides by negative 15, because that's our division property of equality, and it's because I had multiplication. That was the next thing that showed up. I end up with w equals negative 2. Don't forget that negative sign. Positive over a negative is a negative. Now we just check our work, because that's our answer. Negative 7 minus 15 times negative 2. Does that equal, 23. And it does work. Alright? And that's it for 11. Alright, 12. We have 9x minus 36 equals 0. Everything's exactly the same. We have PEMDAS. Look, I have subtraction. That's why I add 36 to both sides to start. I get 9x equals 36 because of our addition property of equality. No more subtraction. There is no addition. There's no division. Oh, I have multiplication. So I divide both sides by 9. I get x equals 4. Okay? Because of the division property of equality. Now I plug it in to see if it works. So 9 times 4 minus 36, does that equal 0? Well, 36 minus 36 does equal 0, so you're good to go. Alright, number 13 is a little bit different. I have 5x minus 7 equals 3x plus 2. So the first thing I have to do is I have to get all the variables on one side. So before PEMDAS, put all the x's or all the variables on one side. And to do that, I'm gonna move this 3x over. So I'm gonna minus 3x from both sides. Now notice I am subtracting the x's. I want this to be gone. I want that to cross out and be gone, and give me just 2 on this side. And then I line it up with my 5x, so now I can combine like terms. 5x minus 3x is 2x. I just drop down the minus 7. Now it looks like just like number 12, just like 11. I have one variable. Now I can use PEMDAS backwards. All right. So there is subtraction. So I add 7 to both sides. That's my addition property of equality. I get 2x equals 9. So I divide both sides by 2. That's my division property of equality. I get x equals to 9 halves. A lot of you might have 4.5. That's okay. They're the same thing. I prefer 9 halves. Now I'm going to check my work. So when I check my work, I say 5 times 9 over 2 minus 7. Does that equal 3 times 9 over 2 plus 2? And I'm just going to do the left side of my calculator, see what it turns into, and then do the right side of my calculator. Well, I'm going to do it in my head because I don't have a calculator. So I do 5 times 9 halves, that's 45 halves, minus, so I have 45 over 2, minus 14 over 2, because it's the same thing as 7. Gives me 31 halves. 3 times 9 is 27, so I end up with 27 over 2 plus 4 over 2, and I get 31 over 2 equals 31 over 2. That's the same exact thing, so it is a true statement. That's it for 13. Alright, so 14, exact same concept. So before I do anything, I have to put all the variables on one side. So before I do my PEMDAS, before you do PEMDAS. Because this only works with one variable. PEMDAS only works with one variable. So I'm going to add 4y to both sides because I want this negative 4y to leave. Alright, that's gone. Notice I line it up with the y, so I get 14y plus 10 equals 4. Now it looks just like something I've done before. I minus 10 from both sides because there is no subtraction. I see addition. That tells me to subtract from both sides because of the subtraction property of equality. I get 14y equals minus 6. Now I divide both sides by 14. I get y equals, guys, if you're not sure what to do here, do minus 6 ABC 14 in your calculator. It will reduce it for you. Or look how and see how 2 goes into both of them. I end up with negative 3/7. Now I'm going to plug it in to the original. 10 times negative 3/7 plus 10. Does that in fact equal 4 minus 4 times negative 3/7? Alright, I get negative 37. It does work out. Alright, good to go. Alright, 15. 13 minus 8v equals 5v plus 2. Now, I always move the smallest variable. So minus negative 8v is smaller than 5v. Alright? So I'm going to add 8v to both sides. Because I want that to cancel. I get 13 equals 13v plus 2. Now I can worry about, now that I have one variable, I can start thinking about PEMDAS. I don't see any subtraction, I see addition. That's why I'm minus 2 from both sides. I get 11 equals 13v because of the subtraction property of equality. Now I divide by 13 on both sides because of the division property of equality. I get v equals 11 over 13. Just leave it as 11/13. Alright? Now I plug it in. 13 minus 8 times 11/13. Does that equal 5 times 11/13 plus 2? It does. Alright? Works out. Alright, 16. 16 is different because although you have multiple variables, so before moving variables, you have to distribute. So as soon as you see those parentheses, you have to think distributive property, or I always talk about the pizza delivery guy. Alright? So 2 times x is 2x, 2 times 1 is 2, so this turns into 2x plus 2 equals 3x minus 3. Now I'm allowed to move my variables. 2x is the smallest, so I subtract 2x from both sides. I end up with 2 equals x minus 3. Now, this is just an easy version of the problem from the first page. So, this step right here, the distributive property, turned that into a problem that looked like, up to 15. And then after that, one step made it look like the first page. Now I use my addition property of equality. I get x equals 5. Now, when I check my work, I put it back into the original. I don't put it into this line here. I put it in the original. So I do 2 times 5 plus 1. Does that equal 3 times 5 minus 3? 5 plus 1 is 6. 2 times 6 is 12. Does 12 equal 3 times 5 is 15 minus 3? 12? It does. So you're good to go. Okay? So in this problem, the first thing I have to do, you have to distribute. Second thing you have to do, move all the variables to one side. So variables to one side. Third, that's when you use PEMDAS backwards. Alright? So you have to do it in that order. So the first thing to do, 5 is the pizza delivery guy. He drops off pizza at 3x's house and 5's house. So I get 15x plus 10 equals 4x minus 8. Subtract 4x from both sides because there's step 1's done. Now I'm doing step 2. And 4x is smaller than 15x. I get 11x plus 10 equals negative 8. Look, I moved all the variables to one side. Now I just do PEMDAS backwards. Minus 10 from both sides. That's my subtraction property of equality. I get 11x equals minus 18. Divide both sides by 11. That's my division property of equality. So my final answer is x equals negative 18 over 11. You can leave it just like that. So now I'm going to check my work. You plug it in. You say 5 times 3 times negative 18 over 11 plus 5. Does that equal 4 times negative 18 over 11 minus 8? Alright, good to go. 18. We have 2r minus 4 equals 2 times 6 minus 7r. Once again, you have to do the parentheses first, so I distribute the 2 to both. I leave the left side alone. 2r minus 4 equals 12 minus 14r. Now I have to move my variables onto the same side. This negative 14r is smallest, so I add 14r to both sides. Alright, that's not a division sign. I don't want you to think that's a division sign. Alright, that was just me underlining. So I get 16r minus 4 equals 12. I add 4 to both sides. I get 16r. Remember, that's the addition property of equality. I get 16r equals 16. I divide by 16. Divide by 16. because of the division property of equality. So my final answer is R equals 1, because 16 over 16 is 1. Let's plug it in. 2 times 1 minus 4, does that equal 2 times 6 minus 7 times 1? 2 minus 4 is negative 2. 6 minus 7 is negative 1. 2 times negative 1 is negative 2. It works. Alright, that's it. Alright, number 19, same exact concept. I have 2 times the quantity, 4x plus 1, equals 12x plus 18. I distribute that 2, so I get 8x plus 2 equals 12x plus 18. I can't start solving until I get all the letters on one side. 8 is smaller, so I move the minus 8x from both sides. I get 2 equals 4x plus 18. Now I use my PEMDAS backwards if I want. I don't see any subtraction. I see addition. That's why I'm minus 18 from both sides. That is the subtraction property of equality. I get minus 16 equals 4x. Divide by 4, divide by 4. That is my division property of equality. I get x equals negative 4. That's my answer. Let's check my work. 2 times 4 times negative 4 plus 1. Does that equal 12 times negative 4 plus 18? 4 times negative 4 is negative 16, plus 1 is negative 15, so I get negative 30. 12 times negative 4 is negative 48, plus 18 is negative 30. Good to go. Alright, number 20. I'm not going to do all of 20, but I will talk about 20. Since you have x and y in the problem, you cannot get a number answer. You can only get one of those variables by itself. No matter what you do, you still have to distribute first. So the first thing I'm going to do is I'm going to get 4x minus 28 equals 36 minus 4y. Now I can solve this two ways. I can get x by itself, or I can get y by itself. If I get x by itself, I pretend like I just do the same thing I would do if that minus 4y wasn't there. If I erase that minus 4y, I would add 28 to both sides first. Now really, you can't just erase the minus 4, right? But you can do that. You can add 28 to both sides, whether that's there or not. So I want to get x by itself, so I do PEMDAS backwards with the stuff that's around x. I see subtraction. How do I get a subtraction? With addition. That's why I add 28 to both sides. So I get 4x equals 64 minus 4y. Now I don't care that there's a bunch of stuff on the right side. I only care about the left side because that's where my x is at. There's no addition, there's no division, there's multiplication. So I divide by 4, which means I have to divide everything by 4. So x equals 16 minus y. That's as far as you can go. Now if I want to get y by itself, this time I got to say what's going on with y. So I'd have to get rid of the 36. So I would do 4x minus 28 equals 36 minus 4y. This time I would minus 36 first. I get 4x minus 64 equals minus 4y. Now remember, I'm getting y by itself, so I divide by negative 4, divide everything by negative 4. I get y equals minus x plus 16. This is called rewriting the equation. We'll go over that tomorrow in class. And it's going to have a lot to do with solving systems of equations, because one equation needs only one variable to get another answer. If you have two variables, you need two different equations to get a number answer. All right? That's it. Thanks.